I think Malcolm doesn't really need an introduction. Malcolm is, in my opinion, and I'm not fully objective, probably the most important researcher in the Pacific Southwest Research Station. He is on everything, and he's working in everything that has to do with fire and disturbance and management. And it's wonderful to have worked with him for many, many, many years. And I'm really excited that he's here today with us as well. He's going to be talking about Western forest resilience. Oh, and I should know, you may not all know this, but he got his PhD at University of Washington, and so he's a direct line to the Jerry Franklin sort of thing, which is I mean, there are not many of them out there anymore, you know. Anyway, great, thanks, Malcolm.
All right, thank you very much, Hugh. It's a real pleasure to be here, and I would just reiterate, I do much better when it's interactive. So if you've got a question, just raise your hand or throw something at me. But fortunately, this talk doesn't really have much in the way of technical terms, so hopefully I won't descend into gibberish here. But I did want to talk to you about a couple of papers that we've been working on that were recently published. And I think they have a fair amount to say about what our forest management is doing these days in terms of the wildfire problem. And so I'm really going to focus a lot on what resilience is in these systems, and also what some of the kind of take-home messages from research have been over the last few years that might be relevant for reforestation. So start with that. This way. Bit of an angle way. There we go. Okay. So I'm going to first just start with this aspirational goal that is currently in California to try for both the Forest Service and CALFIRE to each get to treating 500,000 acres a year by 2025. And I think it's an interesting place to start because I think, one, we want to think a little bit about what's the actual extent of fuels treatments that we're doing in the state? But also, do we really have a clear idea of what we mean by fuels treatments? So first off, just to start, to give you some sense of this, we were looking at this question a couple of years ago in a paper. What's the extent that the Forest Service is actually doing currently in terms of treatments? And so I'm just going to pick particularly on the Sierra Nevadas, which is by no means the whole state by any stretch of the imagination, but at least that's where we had good data. So Forest Service manages about 13 million acres in the Sierras. And by looking at fire regimes and the amount of forests that each one of those was in, you can kind of do a back of the envelope calculation about how much acreage used to burn before the arrival of Europeans, about 620,000 acres. How's the Forest Service doing? If you get into this really archaic data set, they've got the facts data set, you can go through and add up the treatment here. And what you can see is, in terms of the treatment breakout, about 21,000 acres of per year of mechanical, just under 12,000 of prescribed fire. Surprisingly, almost 19,000 a year of managed wildfire. And I'm not going to get into debating that term right now, but we'll just go with it. So you got a total of about 62,000 acres. And as you might well notice, there's just a little zero that's missing next to that. So we're about 10% of where we would want to be. And needless to say, as far as I know, these numbers haven't hugely changed. So we've got 1 year to add 438,000 acres a year to get there. But just to give you a sense of where we're at with this. Let's see if this works. Yeah, okay. So what qualifies as a forest treatment? I've been on the California Wildfire and Forest Task Force for a few years that's been trying to figure out how to answer questions that come up with all these forest treatment things. And one of the ones that came up recently was, what are the metrics that you would want to report when you do fuels treatments? And believe it or not, we started with 110 of them and reduced it to 20 that are core in there. And if you open up the list, you find out it's everything from smoke management to socioeconomic impacts of rural communities to all this kind of stuff that it's almost like it's, you know, the Christmas tree where everybody comes and hangs their favorite ornament on the tree. And the question you have to ask is, you know, what does it really have to do with fuels treatments? I'm gonna just back into like saying, let's keep it pretty basic. And I'm sorry if I'm gonna disappoint you, but I'm not gonna talk about socioeconomic impacts or smoke or any of those other things. I really wanna focus on what we're doing in terms of the forest conditions, both in terms of how resistant and resilient it is to fire, as well as what are we actually doing to the ecological processes. So one of the things I always get a kick out of is, you know, you start with a fairly crowded forest condition, and particularly if you're up in a place like the Tahoe Basin, where they're really paranoid about burning down their $1 million homes, they'll do something, sometimes a treatment like this, which I've heard people refer to as the asbestos forest, or using a clear cut from below. But either way, you get kind of a sense that if you focus really hard on just the fuels aspect of the treatment, you can end up with kind of myopic blinders on as to what you're doing to the rest of the ecosystem. And I think all of us who've worked in California have seen forests to one degree or another that are a little bit overly zealous treated. But one of the contexts that's going on, of course, now is that we're not talking simply about wildfire. We've got these compounding issues, particularly the 2012 to 16 drought that produced, by some estimates, 100 to 150 million dead trees in the Sierras, really compounding the fuel loading question that's going into this as well. And if you're going to talk about resilience, it is a contractual requirement that you have to have a ball and cup diagram. So that is my token ball and cup diagram there. But otherwise, I'm not going to talk about it. This thing's driving me nuts. But I do want to say, you know, if we need forests that are resilient to fire, but they also need to be resilient to other stresses, what are we talking about when we talk about resilience? So I think first off, when I was shoved into dealing with this question, like many people, I read a bunch of the literature and it's kind of overwhelming. There's so many papers out there that you have to realize, or at least I realized, that you had to narrow it down to a particular context. And so what I'm going to talk about is working definitions. And I mean that very strongly. No attempt to definitively define these terms, but working definitions for a particular forest condition, in this case, frequent fire forests. And I'm going to suggest that resistance is really focused on trying to get the forest to persist, and often targeted towards a specific stress. And I think in our case, particularly in the West, we're really focused on the fire issue when we talk about resistance. But resilience is a little more demanding, and it's really a measure of the forest's adaptability or capacity to maintain its functional integrity to a whole range of stresses. And I think particularly, you know, in reference to the earlier slide, we're not talking simply about wildfire anymore. We're talking about drought, bark beetles, all the array of other things that are coming at the forest in these type of conditions.
So are you talking about like the historical range of conditions, or would resilience also include maybe a new kind of community?
I would suggest, I think what you're implying is that we take lessons from history, but I would not try to slavishly mimic it, because trying to go back in time is a fool's errand when you don't have stationary in the system. It's always changing.
So it could be realignment is also.
Realignment as well, yep. So talk about this forest resilience and its terminology, and I refer to it as baggage because I find it a pretty frustrating term, but I'm still going to go ahead and try to define it here in a couple of slides. But to start with, you know, when I first started working in California, the main takeaway was, let's get the forest to look like it used to look like in 1850, and then we're good. We can talk about we need 8 trees bigger than 30 inches or whatever criteria it might be. Oops, how did that happen?
You touch the screen. I can see what happens. Actually touch the slide. See what happens if you touch the slide. Can you just spread it out when it gets? Seriously.
We're trying double tap on the slide.
Double tap.
Derek is just messing with you. He does that stuff all the time. Could you actually drag it out? You think that was weird? You touched it and it just got really small.
It contracted.
Yeah. Literally, just can you drag it, make it get bigger?
Oh.
Jeez. Oh, okay.
Now I feel.
Just don't touch that screen, Malcolm.
I didn't realize I had that.
No, we don't, there's a lot of things we don't know about these new systems.
Yeah. But, okay, so as I mentioned, though, a lot of times, particularly when I first started working in California in the late 90s, there was this real reference on. I didn't touch it. I'm gonna stay away from
Touch
that.
that. Just, keep going.
Okay.
The real question is, are you resistant or resilient to new technology?
I think the screen is being resilient, but I'm resisting. So let me just take a second to see if there's anything I can do about this on this.
Well, we can read it, and do you know, is this happening on, are they seeing this on the screen as well? It's staying the same, to forget.
So it's this screen.
Okay, it's pretty small though for those of you in the room to be able to see.
I can see Carol Merrill and just sit there and keep changing it as it gets smaller and bigger.
So you can go full screen.
Where's that?
Well, it's full screen on his laptop too.
Yeah.
So.
Yeah, that's the
It's like that.
odd part.
I can see it and I can read it.
Okay. Well,
Can you try it one more time?
Yeah. Just stay away from the screen.
okay. If I start walking towards the screen, just throw something, at me, preferably something heavy. In any case, the thing that is it, even though it's a frustrating term to deal with, it has definitely seeped its way into the language that is being used not only in reports such as the Forest Service Planning Rule and the California Task Force on Wildfires, but it's pretty prevalent even in society now in terms of, are you resilient to Oprah Winfrey shows or whatever it might be. It's used in a very broad context. And to my mind, there's a lot of problems with that. Is that you obviously have in the literature, you have confusion about the different types of resilience. Civiculture has its own term, engineering, ecology. There's differences in scale that people are thinking about with these things, variability between ecosystems. And these guys, Brad, no. I don't know if there's anything we can.
Is it happening
I
when?
think it's like when people enter the
Yeah,
waiting
it
room,
makes
it
it smaller,
interferes
yeah.
with the
I think that's right.
screen.
So what's
We need to
doing it?
make it slightly bigger.
When people enter, there a little tag comes up, says somebody has entered the thing. And then
Oh, and
it
that
drops, yeah.
shrinks it down. Okay. Well, those of you who are in can stay in, but nobody knew. In any case, I've always appreciated this quote that's Brandon Jackson said, basically, it's a malleable term that facilitates communication across discipline boundaries by creating shared vocabulary, bridging the gap between science and policy, which basically means it's vague enough that it makes people think that they're in agreement about what we're really talking about. But to my mind, can we even use that as a way of evaluating forest systems? Because it just seems to me like it's way out of sync with the ability to kind of define it as a hard measure of what's going on in the ecosystem. Is there any point, Tara, trying to do anything with this?
The view option at the top.
Yeah, view option. Yeah, let's go look at that real quick. Let's see what it says. But that's gonna be these things. Okay, zoom ratio, hide video panel, exit full screen. Well, let's try that. Let's go.
I'll hit the window, yeah.
Okay. Yeah, but it'll happen again when somebody.
Okay.
Anyway.
We'll see what happens. Anyway, thank you.
So Malcolm, so just want to come back to this point because the 2012 planning rule says that they're supposed to plan for a return to historical conditions. It's written into the rule. So this is a problem itself that needs to be fixed.
Yeah, it is very much, and I'm gonna suggest that our understanding of historical conditions is not really nearly as extreme of treatment as we're presently in. So, yes. So let me start with, I'm gonna attempt to define resilience here, and I'm gonna use three different approaches. Because I think it's actually supported by different ways of thinking about this. I'm first going to use ecological theory, so we'll start with the biggest, then get into what the literature is suggesting in terms of a complementary idea of resilience, and finally look at a historical data set to give us a sense of, does this actually play out? But if you look in theory, what fire is often referred to is very similar to herbivory, in which you've got the system that has consumers controlling the ecosystem biomass and species composition. So if you think about it in terms of the top two slides, if you've got a grass system, the herbivores, if they're held in check by predators like the lion, then you can have an explosion of the herbivores, and the herbivores become the top-down control on how much biomass there is out there. And if you apply that same kind of concept to fire, what you're thinking about is if you treat fire suppression as the mechanism that would remove the rate of fire in the system, if you look at it in a parallel means, fire actually becomes the top-down controller in these forest systems. Because of its frequency, it ends up controlling the amount of biomass, the amount of density, and the size of the trees within the stand. And so without suppression or removing the predators in there, fire is frequent enough to be limiting the tree density and the resource more than resource availability. So i.e. they're not being limited by water, light, nutrients. It's the fire itself, which is actually reducing the biomass and reducing the competition in the system. And I want to mention this quote. It was documented by an early surveyor of timber conditions in the Northern Sierras, a guy named Lieberg, who in 1902 did a survey. And he said, suppression of the young growth has always been one of the serious results of fire. The land does not carry more than 35% of the quantity of timber it is capable of supporting. And I'm going to get back to this 35%, but it's actually a pretty prescient remark about what's going on within these forests. So the second approach to this is using literature, and you have to first start with the question of, okay, historically, these frequent fire forests survived a lot of fires and droughts. What's different now that's fundamentally destabilizing them? And you can say that without fire, obviously the live tree density and biomass is going up. The competition for growth resources are going up, and the tree vigor is going down. And there was a nice paper done back in 2017. It's only one of about several dozen papers I was looking at in terms of what might be driving this relationship. But it was a meta study of, I think, dozens and dozens of radial growth, dendro work papers, suggesting that there's a pretty uniform indicator of what is a reduction in terms of the ability of trees to be able to deal with stresses. And a lot of it has to do with competition. And of course, in forestry, we look at it, I'm gonna go closer. We look at this by the radial growth patterns, ring patterns in there. And I think what I'm gonna propose is that what is fundamentally different that these forests have not experienced in the past is that you would have had disturbances that are stressing the system, but they're not long duration. They're pulses of stress. So you would have a fire event, you would have a drought, but you wouldn't have them kind of constantly going on, like with climate change, the kind of warming stress that we have going in the background, or growing in a condition where you've got really strong competition for growth resources, particularly water mostly in these kind of systems. And so to my mind, one of the things that's really distinguishing present conditions from historic conditions is that the forest is experiencing competition. And competition is a press. It doesn't go away after 1 year or after one event. And I think because of that, you're looking at something that a forest that dealt with these stresses in the past is not necessarily at all adapted to what kind of stress it's facing now, because it's a constant press type of condition. If we look at that in terms of minimizing competition as a way of restoring resilience into the system, do we have a way of measuring that? And that is one instance in which I think we're actually fairly well set. Because civiculturalists have long used this measure of competition within stands, the stand density index, which is simply a combination of the number of trees you have and the size of the trees combined together to give you a sense of how much biomass there is on the site, and by inference, how much competition there is. And certainly one of the things that we have a pretty good record of is that if we take one stress, in particular bark beetles, we know that one of the things that actually drives trees' ability to repulse the bark beetles is to entomb them with pitch, which is a very water-intensive process. And because of that, you've got a direct kind of relationship between the number of straws you've got in the ground, i.e. the amount of biomass, competing for a limited amount of water, and that should be directly related to how resistant or resilient, I'm going to suggest, the tree is to such a stress condition such as bark beetles. In a room full of ecologists, I probably don't even need to explain this, but civiculturalists kind of stumbled onto this relationship that we call the negative, or the power law, the negative 3/2 line relationship, in which on the left-hand graph, you have log scales on each side, and you have the number of instances, in this case trees, on the x-axis, and the size of those trees on the y-axis. And of course, we've done this kind of relationship looking at species, numbers, and sizes, and so forth. And I'm not going to say the law is absolute, but it's been used in enough cases to suggest that it's a general principle about a trade-off between the biomass of organisms and the number of organisms that you have in that ecosystem. And a civiculturalist in the 30s named Reinecke used this to figure out where these lines were for different forest types. So in this case, I'm not sure exactly what forest type is plotted out for, but let's say it's mixed conifer. The dots are individual stands that are out there. And what they do is they sample a whole bunch of them, look at where the distribution of that is, and then have a maximum density line that's constructed from that. And when you're in different forest types, that line is going to be lower or greater depending on how much biomass can be supported. So for instance, a red fir forest that's not so moisture limited is going to have that line moved higher in the thing, and a dry ponderosa pine is going to be moved lower. But it's a fairly strong predictor of the general kind of trade-off between size and number of organisms. The right side, you'll notice, has a striking resemblance to that pattern, but this is a stand density management program in which this is how foresters think about how they're going to develop the desired size and number of trees that they want. So if you look at the bottom of that heavy black line, you'll see that they planted about 1,500 trees. They let it grow for a little while, and then they thin it, and that's where the line jogs back because they're reducing the number of stems, and then let it grow again, thin it, let the line move back, and so forth. And it does this kind of stair-step fashion that is basically what's driving pretty much all the growth and yield models that we use in forestry. Because there's this trade-off between the number of trees you have and how big they can get. And if you want to produce big diameter trees, you need to keep on thinning them to be able to get to that step. Okay, so the third part of this explanation of how we settled on this idea of resilience as a measure of competition, the relative competition. We use these data sets that were taken back in the early part of the century, pretty intensive data samples in which they were using a quadrat system and sampling these line transects that went down the middle of these sections. But 24,000 acres, you can see a 5 to 10% sampling intensity, pretty extensive in terms of the actual percentage of samples that you're getting. And what I'm going to do is show you how the data falls out in 3 different forest types: pine and xeric and mesic mixed conifer. So this is pretty much it in a nutshell. And I don't know whether Scott Stevens showed this figure or not. He may have, because he was a co-author on this paper. But he and I had been both struggling with this idea of what resilience was about. And I think Scott has been particularly sold on this idea. But the pictures on the right-hand side pretty much show the whole story of what the forest looked like in about 1911 versus what it looks like 100 years later. And one of the things to notice in this is that the y-axis in the modern condition, or the 2011, is 10 times the range of the axis in the upper row in there. But if you look at the top right of each one of those graphs, you'll see how many stems per hectare there were, as well as what the average size of those stems were. And you basically went from a forest that had about 50 to 70 stems per hectare and an average tree size of about 70 to 75 centimeters, about 30 inches. And that average size drops in half. And you can see the stem densities go up by about 5 or 6 fold, a huge increase of what's going on there. So if we take that concept of relative stand density index and we apply it to these numbers, the violin plots, I'm not going to get closer, on the left-hand side are the dots in them are actual stand measurements from different stands. And they're paired in a way in which the left-hand set is the 1911 and the right-hand set is the 2011. And they're by the 3 different forest types on there as well. But the message that I'd say take home is pretty clear just from the violin plots itself, the way they're inverted, the way they change from being bottom heavy in the historic condition in 1911, where about 70 to 85% of the stands are in what civiculturalists call free of competition or partial competition going on within the stand. But if you look at the modern condition in 2011, it's inverted. And you basically have about 80 to 90% of the stands in what is classified as full competition to the ominously referred to zone of imminent mortality. And that's the zone in which if you continue to let it grow, the stand will start to self-thin itself because there's too much competition going on between the various stems to be able to support the amount of biomass that's in the condition. But to me, this is it's a relatively clear picture of what the relative intensity of competition was in that forest when it had active fire in it versus what it's like now. But the question, somebody would say, well, so what? So, competition is the driver of how forest stands are really managed now. And because of that, I'd say that the more you kind of let this concept sink in, that resilience is a level of very low or no competition, you realize how at odds the historical forest was with the way we manage and think about forests in the modern era. Because I put this emblem up here for the forest vegetation simulator because that's the growth and yield model that's used in the Forest Service, but actually widely used by other organizations as well. And what drives that is this stand density type diagrams I was showing before, in which you plant the trees at a certain number, you thin them, and you start working your way back up until you're fairly close into the y-axis, but higher up, so you've got a few larger trees. That's basically the way we manage stands most of the time, is manipulating the competition to get us to the desired condition. But this is saying, whoa, we don't want to get the forest into a state of competition. We want to be able to keep it relatively competition-free because that's what gives it its resilience. That gives it the ability to deal with the drought, the bark beetles, and so forth. And so you kind of would first say, well, you know, what's the big deal about competition being bad? It's really the fact that that's pretty much the man behind the curtain, if you think of the Wizard of Oz scene, that's pulling the levers and making everything run. Competition is the way we pretty much manage and think about stands. And what's interesting to me is that the Forest Service in particular thinks about relative SDI as something in which you never want to go below 35% because the stand's too open to even be competing. So it's not really moving in the direction that you want it to. But at this point, I'm suggesting here that what we're seeing is we want resilient forests. 35% should be the maximum, not the minimum. And when you look at this in terms of the way the forests in Region 5 in California are classified, the Forest Service claims that you really only need to start prioritizing treatments in stands that have relative SDI of 60% or above. And if you take that as the correct method, then in these three different forest types, the pine, the xeric, and the mesic mixed conifer, you're treating 48%, 25%, and 0% of the three different forests. But if you invert that and say, okay, we don't want to exceed 35%, what happens to those percentages? You're looking at treating 96, 91, and 100% of the stands out there. So this becomes a really serious, heavy lift if you decide to buy it. And I think that, at least to my mind, the evidence is reasonably compelling, but the level of treatment that you have to do to get down to a competition-free environment would probably not go over very well with the public because you're talking about 20 to 30 trees per acre, a very wide open forest. And oftentimes, at least in the public meetings I've been in, when people do fuels treatments, they're talking about taking the forest down to maybe 150, 125 stems per acre, not taking it down to like 20 or 30. So the problem is that to my mind, what we're really engaging in when we're doing fuels reduction is we're doing resistance. We're doing temporary resistance to one specific stressor fire. And as all of us know in this room, you can thin the stand down and reduce the surface in the ladder fuels, but of course the stand's always growing. So within like 12 to 15 years, you have to treat it again. If we're really going to commit to doing something out there, to my mind, if we're going to go in and treat the stands, we should think about taking it to a much, much lower density where we're really dropping below the competition threshold and getting better effectiveness in terms of how we manage stands. Is typically we move them back and forth and roughly where the red line trajectory is at. But if we were to do this more in terms of keeping the stand density low enough to avoid competition, we'd actually do a trajectory more like the green line there.
Which is probably more consistent with what the Forest Service can do now because they don't do thinning. They can't.
Mm-hmm. Yeah, unfortunately, the thinning that, at least the thinning projects I've been involved with, they take 3 to 5 years. There's a lot of contention about them. They're generally done on a fairly modest level because they're not trying to upset the homeowners that might be near these stands. But you're not getting down to that competition-free zone by any stretch of the imagination at all with those kind of treatments.
Yeah, so if you get to this 35%, you need to make sure that there's something that is keeping then the system open, because I come from Spain and everyone there is like trying to do some thinnings, but keeping the canopies close enough to avoid the light reach the understory and to avoid the understory to grow up, because we don't see fire as a so recurrent disturbance. So we are afraid that if you cut too many trees, you will get too much light and you will get all this understory again, and then you will have all this very dense forest again soon. So once you have the 35%, you need to make sure that some disturbance is like keeping the system open.
Well, that's the second obligation to this, is if you really are going to go to this resilient state that's below this 35%, you're going to have to maintain some level of disturbance, whether it's going in with masticators and chewing up the shrubs, or preferably with prescribed fire. But if you just reduce the stand structure and then walk away from it, you're not gonna have a very lasting effect at that resilience. So it's kind of a two-pronged approach that unfortunately is gonna require a lot of commitment. And particularly, at least from my perspective, you know, trying to work with the Forest Service over the years, there's no way in hell they're gonna be able to do that with thinning or mechanical type of treatments. You just can't even get in the equipment into many of these places. So they've got to make peace with working with fire. I just don't see any other way of doing it.
How about herbicides?
Pardon?
How about herbicides?
Well, herbicides are controversial, but I do think there's a definite role for them, and I'll talk a little bit about that when I get to the reforestation part of this talk. So before I move into the reforestation, though, I want to kind of just hit quickly on 3 points that I think have really come out of a lot of the effort that's gone into understanding frequent fire forest systems. And to my mind, there's a few salient kind of take-home points that we've gotten from that research that we should keep in mind, particularly as we're designing reforestation methods. And one of them is that, as we know, pretty much now, there's been a lot of work done showing that in forests that historically had frequent fire in them, you have a very distinct type of pattern that people call ICO, or individual trees, clumps of trees and openings. And the figure in the table here from a site down in the Sierras, in which we reconstructed this back in 1929. And the yellow there is the gaps within the forest. And about half of the forest was in an open gap type of condition in those active fire conditions. But the point that I think here is that you gain for several reasons. And the first one of them is that this spatial pattern has been shown fairly recently, but to be more fire resistant than a system in which you have more even distribution of trees. And a lot of it has to do with the fact that the openings have reduced surface fuel loads in them, but also the open structure of it actually reduces the wind's ability to do transfer of heat, radiant and convective heat, into the overstory crowns of the trees. So you start building in a better resistance to crown fire using a pattern like this. And Mike Kunst, who is a student here, with a really nice paper showing that in various forests. The other one that just kind of comes from some of the background I've had in terms of running an experiment in the Southern Sierras that was called Tea Kettle, is we were really interested in the relationship between the forest structure and processes going on. And these are plots of a 10-acre area, or 4 hectares, showing the distribution of things like structural measurements like gaps and ceanothus cover and litter depth. And if you look at the bottom row, you'll see that there's a pretty tight coupling between the structural distribution and the distribution of these resources like PAR, photosynthetically active radiation, nitrogen, or soil moisture. But to me, it's a two-part story. Is one, there's a tight coupling going on, but also the variability in there between the peaks and the dips really suggests that the heterogeneity is hardwired into the system because of that variability in the structure. And I think that sometimes we think that if we just go in and reduce the fuel loads, we're doing fine. But to my mind, this heterogeneity is what perpetuates the desirable kind of fire effects that we get in the system, because the fire reinforces that patchiness, and the two end up being able to kind of sustain a level of low intensity or low frequency fire that produces this kind of heterogeneity into the system. So the other thing I'm gonna ask here is that if we know that heterogeneity and low densities are important, are these characteristics being incorporated into future forests? Because frankly, although we focus a lot on fuels treatments, wildfires having way more of an impact out there on the landscape than any of our fuels treatments. And even if you just look at the amount of high severity, which is the areas we're going to focus on for planting, you're still easily looking at 5 to 10 times the amount of acres produced every year by wildfire compared to what is actually produced with fuels treatments. So the first place for my mind to start, just to give some context, is Hugh and I are part of a larger group in here working on a paper that's in review where this graph came out on the right-hand side. But it's showing basically both the estimated annual amount of reforestation need, which is the red dots. But then the fact that if you don't plant those areas in the past, they start accumulating into the gray bars that go up. And you'll see that there's a tremendous backlog in terms of the acreage out there in the Western United States that needs reforestation efforts. And the reason why I want to point this out is that we should be very careful about how we plant the trees that we're putting out there, because we don't have a huge amount of stock to work with, and we're backlogged on it, at least for I would say for the foreseeable future. So how do we reforest after fires? Well, typically, we have crews go in and plant the trees on a regular grid system, parallel lines. Even civiculturalists refer to it as pines and lines, because largely that's what you're looking at. And a typical prescription, for instance, in California is 12 by 12 spacing, which is 300 trees per acre that you would plant out there. There's reasons for doing this. Obviously, you're bypassing using seed in that kind of very vulnerable stage by putting seedlings into the soil. If you're widely spacing them, you get rapid growth. The crowns are designed to interlock after a while and shade out competing vegetation, particularly shrubs in this case. But you have to ask the question of, does this high density that we're planning at have any natural analog? And it doesn't, as far as I know. I can't think of any forest that's planted on a regular basis like that. And furthermore, you need quite a bit of effort put into course correction to deal with this. So the gray table shows you the current recommended reforestation levels for several species in California. And the bottom actually comes out of, a lot of it comes out of a report that Hugh did with Jen Stevens, looking at the historical levels of the density. And you'll notice that generally the number of trees being put in the ground is anywhere from 3 to 4 times the amount of trees that you would have in the mature forest. So you're either planning on a hell of a lot of mortality, or you're going to end up with a much denser stand than you would have had historically. The right-hand figure I won't go into too much, but if you think about the fact that you're planting a lot of trees out there, you either need to go in and herbicide or reduce the competing vegetation, the shrubs, or you need to go in and pre-commercially thin or PCT the stand to reduce it from, let's say, 300 stems down to 150, and then you go in again and you maybe get it down to 100. But it's a fairly labor-intensive type of approach. And if we think back to that slide of the nursery backlog in terms of seedlings, you have to ask, why are we planting 3 to 4 times the number of seedlings that we want to have in the mature stand when we have a real limitation on the number of seedlings that are being produced?
And I think there's a real overestimate too of, well, maybe it's baked into the system, but silviculturalists, I mean, they love trees, they want trees to survive, and they tend to overestimate the amount of mortality they're gonna get. I mean, even under current climate, the west side of the Sierra Nevada, you're usually getting 70 to 90% survival.
Yeah.
So that mortality isn't happening. On the east side of the Sierra, it's different. There's a lot of mortality on the east side, but
exactly.
yeah, it's, anyway.
But I'm always kind of surprised because there's this view that, oh, we're gonna put a lot out there and a lot of them are gonna die, and the ones that are left by pure chance are in the right places that are, favorable for growing trees. And a lot of times it's just that, there's a fair amount of random stochasticity in which trees live and they die. But either way, if you start out with 300 stems per acre and you want to end up with 50, you're losing, you need to get rid of 250 stems somewhere along the line between age 1 and age 100. So, but the other thing is that it's pretty clear from all the wildfires we've seen go through these plantations is they burn like crazy. They, to say that they have 100% mortality doesn't even quite do justice to what you often see, which is levels of incineration in which the tree is either partially gone and the foliage is all gone. The fires that go through these stands are really quite intense, and obviously they do not seem to be, when they're planted in lines like that, they do not seem to be very resistant to fire at all. The other thing I'm going to suggest is that if you put them all in a regular pattern like this, basically the resource capture area around each tree is identical. And so if you get to a certain point where you're past the tipping point of what the tree can survive, it's not like one tree is going to fail. it's likely that many trees will fail at that point because you're basically creating the same kind of resource extraction or capture rate around each tree. And you have to wonder why this is a pattern when, when we look at these forests with active fire regimes, it's very clear that there's a clustering pattern going on within these forests. And so a student that Andrew and I had, Hannah Fertel, a few years ago, said, why don't we look at those forests and see what the pattern is like? And if you look here in the top, you'll see that the bars of different colors are different sizes of clumps or clusters that the trees are growing in. And only 1/4 of the trees, 25%, are actually growing as individuals. All the other trees in the stand are in clumps of various different sizes that are developing in the system. And so the reason that a lot of civiculturalists won't plant this way is they figure that the trees are going to compete with each other and grow much slower. And because they're all clumped together, they'll be fairly susceptible to fire. But it turns out that at least a lot of the stands I've seen in these things, you get fire like in this stand that's in the picture, in which the fire kills the rind of the outside of the clump. But a lot of the trees inside of the clump actually get through this. And it seems to be kind of a mechanism in which you perpetuate a certain degree of trees, even in a system that has frequent fire going into it. But the other big devil, I think, in reforestation, at least in the minds of civiculturalists, is these incredible shrubs that are depriving the trees of the resources they need. And the left-hand side does show a picture of the Eiler fire, which is in Northern California that burned at high severity. And you can see what it looks like 5 years after the fire. And that site actually has trees on a 12 by 12 foot spacing. But when we were crawling through the shrubs in there, we could not find a single one alive. They were all had been overtopped and died. And right next to them, we had planted clumps of seedlings, and the clumps were doing just fine. And it's because they seem to be able to get a lock on the site and defend it from the shrubs encroaching on it, because they create their own shade within that particular area to keep the shrubs from being able to encroach into the tree growing area. The other part of this, though, is if we're talking about this, is the point we're talking about, is that you really can't sustain these type of conditions, particularly those low density type of conditions, unless you have fire going back into the system. And by now there's about 8 to 10 studies I've seen where they've actually put fire into stands that were 15 to 20 years old and generally had pretty positive responses out of them. It really seems to be that if you're careful with when you apply the fire and how you apply the fire, you can actually use it as a silvicultural tool to thin the number of stems out there while you're reducing the fuels. And part of that seems to be is that if you time it right, the shrubs have taken up a lot of recent moisture if you've had a rain event, and the shrubs become a really effective heat sink that reduces the fire severity between the trees, and therefore reduces the fire actually burning into the trees as well. So we think of shrubs as like something we desperately have to get rid of most of the time, or at least a lot of civiculturalists do. And my sense is they historically had an important function within these systems of being able to create greater heterogeneity in the system, but also being able to reduce the fire intensity in the system. So anyway, in conclusion, anytime you walk into a stand with active fire in it, the regeneration looks substantially different than anything you're going to see in a pines and limes plantation. And certainly after high severity fire, which is a lot of the fire we're getting, you get really extensive shrub or shrub growth, which can basically swallow up seedlings if they're planted on an even spacing pattern. But clearly, to kind of maintain some of these conditions, we're going to have to work with fire to be able to reduce shrub cover as well as the role of density within these forests. Thanks.
Hey, we've got plenty of time for questions, if there are any.
Well, I'll convey some questions / comments from the chat, and maybe you can expound on them.
Sure.
So much has been said here about the characteristics of the historical forest, but little about those factors that gave rise to the historical forests. Implicit is that natural events created those forests, but there's plenty of evidence that indigenous peoples' use of fire was a significant factor in creating historical forests. This is an important element in developing strategies that, in managing our forests that is often ignored. Do you have an opinion, or would you like to?
It's a great comment, and it's simply because for shorthand and not being able to deal with that kind of issue within the context of this talk. But a lot of the systems that I've seen are starting to explicitly roll or combine cultural burning practices into this idea of managed wildfire as well as prescribed fire. And I think that the more we can learn from cultural practices and include them in this whole process would be a real advantage. Because my hunch is that, you know, the cultural practices had a real design on producing certain products that were useful to the indigenous community. But to my mind, you probably, to be able to get that, you probably needed a fairly patchy or heterogeneous fire effect, which is exactly what I would think is what we need in the system as well. So I support the comment completely.
And related to that, you showed a photograph of a cabin in 1911 and then like recently. But 1911 couldn't have that forest been logged by then?
In this case, it's in an area where there's fairly decent records, and as far as we know, there was not logging in that particular place. And it's the reason we actually have a record is because that cabin was I think a guard, what they called the guard station in those days, but became the Forest Service. And so they had a record of what was going on right in that area. But you're right, it could have, you know, there, particularly in Northern California, there was a lot of logging that went on in relationship to the mining that happened there. And so you do have to be careful about the way you interpret it. But one of the reasons I picked that site is we seem to have a fair amount of written history about it because of that.
Since nobody else is jumping in, I'm going to ask you a question, which is not a trick, because most of the work that I do is in the Klamath Northern Coast Ranges ecoregion, where the forests are substantially, I think, in many ways different from Sierra Nevada forests, where broadleaf vegetation, basically oaks and their close relatives, are an alternative kind of natural climax community, probably maintained both historically and currently until very recently by fire, which was probably partly indigenous and probably likely, in fact, probably natural because that area suffers from periodic lightning storms. And so large areas burn, you get large prairies that are these grassy bald areas with no trees, and they're natural. They're not being maintained by anyone, although probably the sheep grazers for much of the early 20th century probably had an adverse effect on natural dynamics. But the dynamics in the landscape appear to be different. On the other hand, I think everything that you've said here on Forest Service lands is absolutely appropriate. And I have had numerous conversations with silviculturalists for Northern California forests, and they all know that 35%, the relative density should be 35%, but they never do that. It's really more like their target is like 60%.
Yeah.
And they would like to be able to go in and do multiple fence, but they can't because pre-commercial fence have to come out of the budget and they don't have it.
Yeah.
Right. So I don't know how we resolve that. I'll give you one example though. We had on the Mendo, we had a forest silviculturalist from the Northern Rockies was here for 2 or 3 years. And he was working on a project called the Four Beetles South Project on the northern part of the Mendo, it was an old area that had been logged previously and it had been burned. So it had gone through a couple of different kinds of disturbances. Many shrubs, various ages of natural reproduction, and only a few trees bigger than about 15 or 18 inches. So his target, the prescriptions he developed for this regional plan were basically to create minimum spacing of like about 20 feet between trees and to reduce the total cover to less than 35% of relative density. That was his target. He's no longer there. Unfortunately, he's gone back to the Northern Rockies, but after that was executed, I really liked what I saw. It just, I mean, the number of trees per acre was down to around 15 or 18 trees.
Yeah, well, you know, where I see conditions like that get down to about 35% is when you go in post wildfire and you're looking at the moderate severity places where you get, you know, maybe 25% of the trees or whatever make it through the fire. But when you look at least the stands I've been at that have burned in the past and you've got 4 or 5 years out of them and so forth, the two winners that really seem to be coming out in those open conditions are hardwoods, particularly black oak, and incense cedar. And those two are probably gonna take over the world, at least in California, I think.
You're not cone pine in northwestern California.
That's true, yeah, yeah. But I mean, it's, when I walk into a stand like that, I feel like this looks pretty good, but I know most people think it's absolutely devastating. And part of it is you know, you grow up with a certain type of forest condition that you're used to. And so if you're used to 300 stems per acre, even when you do a very modest fuel reduction treatment that takes it down to 150, people sometimes are often still appalled with that. And to my mind, they should have taken it down to 50, not 150, but yeah.
Yeah, so you wanna go ahead and go ahead and ask
Well,
one.
I will, since there was a comment that related both to 35% and to wildfire. So running fire through a 35% stand density index would reduce prescribed fire escape risk to a very low level, making its use much more realistic. Perhaps we could start by running fire through large fire scars after preferred species establishment, thereby keeping risk low while killing stands.
Yeah, in fact, on one slide early on, I referenced a pyrosilviculture paper did back in with a whole bunch of authors here and places, but we said that one of the biggest missed opportunities was because wildfire is having by far the largest effect on the landscape. Don't just spend all your time, you know, beating your head against the wall, getting litigated about salvage logging and replanting the high severity. Spend some of your energy on the low and moderate sites because the fire's done the first treatment for you. And you can go in and we mentioned in there, go in, look at what remaining fuel loads there are that bother you, ladder fuels or surface fuel loads. Put prescribed fire in there and get it in there so that you're building on that reduction already that the wildfires enabled you to do. But to me, it's a huge opportunity that we just seem to cast a blind eye on because we're so busy about trying to get logs to the salvage mills and to get trees back in the ground on a regular type of spacing that we miss that whole opportunity. But you know, even in the intense fires we have now, with 50% high severity, it still means that half of that fire footprint is in probably lower moderate condition, where if we just nudge it a little bit further, we could really leverage that treatment.
Okay, that's my question. Yeah, well, I'll underline that. I mean, you know, we built a restoration strategy for California for post-fire conditions that seeks to draw people's attention more to those parts of the landscape where we can be happy with what happened, and let's not forget those, that we can do things in those places anyway. But, okay, so I want to build on what you're talking about. And so, and this is kind of a trick question, actually. So what happens, you know, so right now you're working, your work is largely, and my work is largely, and in California, our work is largely in systems where we have this nice, happy condition where reducing fire risk, for example, to human communities and infrastructure just happens to be nicely parallel with restoring forest conditions that have more fidelity to whatever the past or maybe to the future, but also will provide us ecosystem service benefits and restore the forest to a sustainable condition. A lot of the world's fire vegetation is not like that. Lodgepole pine in the Northern Rockies, chaparral in Southern California, knobcone pine stands. So if you're interested in natural, you know, this is gonna be an opinion you're gonna give, I get it. But if you're interested in kind of where natural systems are being pushed by where the climate's going and where fire regimes are going and where human demographics are going, you're gonna have systems like Pinus halepensis in Europe or Pinus attenuata in the US or chaparral or there is not a parallel between reducing fire risk and improving ecological conditions in those systems. So I'd like you to just think out loud about how would you approach a system like that where you don't have that nice happy medium of, okay, whatever we do here is great, let's just do more of it.
Get the people the hell out of this. I mean,
Yeah, right, that's a good first step, right? Yeah.
But I mean, you know, it is when you listen to people like John Keeley or whatever dealing with chaparral systems, you know, one of the biggest things he's always pushing is we need to change the zoning law so that we're not building homes in these places that we know are gonna go up.
The insurance industry is
Yeah.
delivering that message right now.
Yeah, they are.
Yeah, I know, particularly when you have an entire insurance company leaving California. And I hear you because the stand replacing systems are, you know, there's no two ways around it. You can delay the inevitable, but it's inevitably gonna burn, and any type of structures you've got in that system are really gonna be at risk. To my mind, if people wanna build homes in that, they can go ahead and do it as long as they're, you know, sign a release form that says, we know the Forest Service is not gonna charge in like the cavalry and save us. And we just value living here, but I think people have a certain degree of responsibility to know the forest system that they live in, and if they decide to take the chances and deal with it, then that's one way of at least reducing it. Unfortunately, the Forest Service will still probably go in and try to prevent the houses from burning down. But I do think that there are, because it's such a common stand replacing fire is such a common fire regime that's out there, you're gonna have to eventually make peace with it in terms of either keeping people out of it, or if you let people into it, that they're gonna have to be aware and take on the responsibilities of what they're
So
doing.
just to follow up on that just for a second, there are National Park Service units in Northern California that don't have homes filling them, who have been trying, and I'm not criticizing, I'm just saying what they're doing, and in fact, I think I support it in some places, trying very hard to keep their parks from turning to knobcone pine by active removal of knobcone pine wherever they can do it, but that's where the system's going.
Yeah.
You know what I mean? Anyways, it's kind of interesting, right? These kind of things like we're all about natural processes. Oh, maybe not.
Yeah, well, it's
You
only
know?
third
The
rank.
Forest Service
Yeah.
literally hates knobcone pine. They won't even consider using that as a potential species, just, you know, create cover, not considered.
Do you guys remember Sarah Bisping's talk? That was one of the things she wanted to use in this big, you know, adaptive management thing they're doing across the state, where the common garden experiment of all these plants. And I asked her at the beginning, well, obviously you're gonna plant knobcone pine, because that's where a lot of the system's going. And man, the foresters in the advisory committee were like, you are not planting knobcone pine. We are not doing that. We're not going there. No, thank you.
Yeah.
I thought that's kind of a missed opportunity. Anyway, sorry, any other questions? I'm sure they've got the other
Evil
ones online.
knobcone pine.
Yeah, the evil, yeah, it's gonna be covered.
Yeah, I gotta say though, do you know what the closest relative of knobcone pine is? Monterey.
I should, yeah, I was gonna
Monterey
say
pine,
Corey pine.
Which in New Zealand is called radiata pine, and
Yeah,
it's these
it's
tall,
everywhere.
straight, right?
I remember when I went to New Zealand, I thought I was gonna see this pristine world, and it was some of the worst forestry practices I've ever seen. But, yeah.
Going back to the reforestation backlog, is that mostly happening on public lands? And so my second question is related to why we're planting at such high density, reforesting at such high densities. Is that just because of our previous cultural focus on timber production, or does that have to do with carbon offsets? Anything like that, do you know, or?
So first, and most of what you're seeing on that graph is indeed public lands. The privates actually jump on their stuff pretty fast, and they usually have their own nurseries that they're drawing from. And I've seen actually them hauling logs out, salvaged logs, while the fire is still burning, and they're planting about a week later. They're on it right away. In terms of the thinking behind planting at higher densities like that, a lot of it is, I mean, I'd like to put a better spin on it, but a lot of it is force of habit, in that you put in a whole bunch of stems and you're a timber management agency, even though you're called the Forest Service, but you're still a timber management agency. And, you know, you put them in and you control how fast they develop with pre-commercial thinning for maybe the first 1 or 2 cuts. And then after that, every time you go in, you get commercial product out of the stand. And so even though the 300 is crazy, at least from the ecological standpoint, it does give you a return on your thing if you're going back in and thinning the stand. But, you know, as the numbers I was trying to show in that one graph where it's just not happening very much. And that's because almost all the money in the Forest Service goes to fighting wildfires these days, rather than going back in and doing stand maintenance and what they call stand improvement, which is basically thinning to shove most of the diameters up to a higher thing and reduce the density of the trees.
Well, and I was gonna say, and don't forget that it's those companies that you're talking about that own all the mills.
Yeah.
And so they've got their own outlet to send that material, and the Forest Service is competing for space that these days actually doesn't even exist anymore. There's very little space in mills for Forest Service product.
Yeah.
Particularly in big fire eaters, you can pretty much forget it, right?
Yeah, you pretty much can't get,
Yeah.
I mean, you know, when they do bid on a tree that's like $8 for the tree or something like that, which if it was alive would be worth more like several $100s. But the system is saturated basically with salvage logs at this point. And so it's really hard to take them anywhere. On the east side, we don't have anywhere, east side of the Sierras, we don't have anywhere to take product.
Got one now, Carson City Mill.
Yeah, but you actually have to pay them to take the logs up there because they've got so much to work with.
Exactly. At some point, it'll get to a point where we can do it.
Do tar.
Well, just to convey a few more questions and comments from the chat. One is about, from Jonathan Long, I want to mention the recent accomplishments on the 6 Rivers National Forest last year in getting fire to accomplish ecological and cultural objectives. We need to celebrate that achievement and figure out how to advance it. And another question from the chat that had a lot of thumbs up, so I know it's popular. Since the publication of GTR 220, do you have any new insight or recommendations for the ecosystem management strategy based on what has been learned since?
Well, I will say, GTR 220 was a publication several of us did back in 2009, but it really emphasized trying to create heterogeneity on the system by paying attention to the topography you're working in. And to my mind, that's kind of exactly what I'm trying to propose for the reforestation is rather than treating it like a blank slate that you're just gonna plop a tree in every 12 feet, pay attention to what's out there, look for the sites that have higher moisture in them or that have shading, because it's just crazy to keep on planting trees in a climate change driven world on a regular type of spacing. And, you know, acknowledging up front that if you're not gonna get in and thin them, you're probably gonna, 80% of them are gonna die eventually. But I'm with you. I think the mortality estimates are way higher than you actually get. I get out there and I see stands that have stagnated because they've got 300 stems and each one of the trees is about 4 to 6 inches in diameter and nobody's gotten in there to pre-commercially thin it. And so the stand's just, this dog hair thicket of stuff.
Are soils, like water holding capacity, part of the planning of reforestation right now?
It's not currently. In fact, I've seen people even put trees repeatedly into places where the soils are only like, 20 centimeters deep, but they have to put a tree in every 12 feet. So they put a tree in every 12 feet. But to my mind, that's part of what we're trying to talk about with this new reforestation thing is pay attention to where it's wet. And a lot of what makes a site wet or better is the water holding capacity of the soils. And so you really need to pay attention to it because it makes a huge difference into how much you can actually hold there. The depth of bedrock, but plus how porous the soil is. So.
Question. How do you think about the kind of spatial arrangement of treatments? And, do you prefer like many small treatments, like just distributed, or like large blocks of treated area? For example, if you have some stands that are, they meet your resilience criteria, but they're surrounded by homogeneity and high density, are the effects of resilience still there when wildfire comes through?
Yeah, I mean, I hate to say it, but at least my experience has been, I've seen places, particularly, I've worked a lot in this area called the Dinky Collaborative, which is down northeast of Fresno. And for a while, it was one of the more aggressive places of putting in treatments because they had money for it. And the problem is that they had reduced the density, maybe not as low as I would like, but their stand still got hammered because you're in a matrix that has a really high density stress level to it. And when the drought came through in 2012 to 16, the beetle populations exploded. And when they get to a certain point, they will simply destroy the stand that is even thin to a lower level. So if you can't do this on a reasonably large scale, you're basically taking the watershed and saying, we're all in the same lifeboat. And unfortunately, if that lifeboat is overstressed because there's too much biomass in it, you're gonna get mortality even in the stands that you've done treatments in.
So your argument is for much larger areas of treatment?
Yeah.
In essence, yeah.
This is playing into a discussion that we're having right now because of the Northwest Forest Plan update. You know Paul Hesberg, I'm sure, right? So he's a landscape ecologist. He's talked at length, a great length, with the PNW forestry community about landscape scale treatments. So you're not just, doing a treatment on the basis of a 60-acre stand. You're basically planning, it's the Jerry Franklin approach, basically, where you're looking at maybe 10 square miles is your treatment unit. And so you're planning within that entire landscape where you're going to do what kinds of treatments, where the soils may be wetter, there's enough moisture to be able to put in an area that you expect to get to be old trees, and where the soils are thin and it's very dry. So you're planning the basis for your landscape management on this larger scale rather than the stand-based scale, which is one of the problems that the Forest Service has because they work on stand-based scales.
Yeah, and the pods are at least an effort to shift that a little bit towards defensible units. So pods is a potential operational delineation, which is basically part of the landscape that you can kind of contain or hold the fire within. And there's most of the West now is divided up into pods. And at least that makes some sense that you're kind of defining the size of that lifeboat. But I also think that watersheds sometimes, if you don't know, watersheds can also serve as a kind of balance type thing. But you're right. I mean, the stand focus, we love to fiddle with it and talk about it and so forth, but it's a drop in the bucket of what we're doing.
Anything else online?
Question about reforestation post-fire. Do you have a recommended spacing for the seedling clumps that survived better in dense? For seedling clumps that survive better in dense shrubs, and how many seedlings per clump?
Yeah, Mark Meyer and I have been doing this little primer of what we were talking about in terms of planting in a different way. And mostly what we're looking at is 25 to 35 feet between clumps, but you don't say, oh, I'm at 25 feet and the trees have to go in here. You look for areas around there that either have shade or water in them. And then within the clump, you're planting anywhere from 2 to 5 trees, generally spaced about 6 to 10 feet apart, figuring that you're maybe going to lose about 20% of them and that you're going to get to a desired clump density and number with that mortality.
Do you have thoughts on what would be like a minimum acceptable return, like management return interval following like an initial restoration? Like I imagine like optimal would be like mimicking the natural fire return interval, but if that's like too frequent for the limited resources we have, is there some rule of thumb you use or could suggest for like what's the minimum we could get away with and still maintain resilience?
Yeah, I mean, I would defer a little bit to Hugh on this, but I will say that generally, let's say you're in a mixed conifer that used to burn every 15 years. I think you can, if you really push it, you can get close to maybe 2 intervals before the fuel conditions get out of control. But if you miss more than 2 fires, then I think you start really digging yourself into a hole when you put something in. So you could roughly double the fire return intervals. What do you think?
It's probably about right, yeah.
It's just a rough, I think that's kind of when they define what condition class 2 is versus a 1 is that you've missed 2 fires or something like that.
That's when when you go to the modern is you miss about 2. That's right.
So anyway, that just rule of thumb, but I can't think of any better thing at this point.
thank you very much. Well, cool, thank you.